And then the second one, this ln, that came up before, and I told you to ignore it because we've never done it. The natural log means the same thing as log with a base of e. So when they ask you to graph the function natural log of x, that's just a log parent graph. That's just f of x equals log base e of x. And with log graphs, they have an x-intercept of 1, and then e comma 1, so 2.7-ish 1, and log graphs look like that, with the same domain, range, and asymptotes as all your other log graphs. So there's really no difference. This is still an exponential function. It's just kind of a decimal type base. And this is just another log function with a decimal type base. But all the other features are the same. The important part is that e and ln are opposite operations. So e's are going to come up a lot in exponential word problems. So if you look down at 2, which is really the most important part about all this, they give us an equation that's telling us the population of llamas is modeled by this. So P is the population, where T is the number of years. How many llamas were initially there? Initially is always when time equals 0. So all we would do is plug in a T of 0 into our calculator and solve. If you type in 500 times e to the 0.035 times 0 power. Does anyone know what you're going to get? Nope. 500. The reason we get 500 is because this is just e to the 0 power, correct? Anything to the 0 power is 1. 500 times 1 is 500. Okay? Algebraically determine the number of years for the population to reach 600. So the population reaching 600 means P is 600. We're going to solve this the same way we solve any other exponential equation. Get the exponential part all by itself by dividing the 500 over. I'm going to reduce that to 6/5. Here, rather than taking the log of both sides, we're going to take log base e of both sides, kind of that other method. And log base e is just ln. If you want to cancel out an e, use ln. And later on, when we want to cancel out ln's, we're going to use e's. They're opposite operations. So I'm just going to take the ln of both sides. That's going to cancel out the e. And then I can solve for t. Divide both sides by 0.035. And then type this into my calculator. The natural log of 6/5 divided by 0.035 gives me a time of 5.2 years. Good? Flip to the back quickly. I'll see if there's one. This whole section is just going to highlight the fact that the natural log and e just cancel. The natural log of e is just 1, because that's log base e of e. The natural log of 1, you could just use your calculator, is going to be 0. On C, ln of e cancels, and that answer is just 5. In D, the ln and the e are going to cancel, but not before we make that radical an exponent. ln of e to the 1/2 power first. Now when you're taking the ln of e side by side, they cancel, and your answer is just 1/2. It's just really highlighting that ln's and e's cancel each other. So one last thing, if I go down here, ln's are still logs. So the whole expanding and condensing rules all still apply. So if I want to expand this division expands into what? Subtraction. So that's the ln of x cubed minus the ln of e squared. The x cubed, that exponent can go out in front, so that's 3 ln of x. And what happens with ln e? Cancels, so it's just minus 2. And your answer is option 2. And that covers everything. The bottom there is just another word problem like what we saw in the front.